We look good? So, have any of you heard the name Robert Maynard Hutchins? It's okay, he's a little obscure. He's a controversial figure in education. From the late 1920s through the early 1950s, he was the president and then chancellor of the University of Chicago. And in an address to the class of 1929, he talked about the purpose of a university education. He told the students the purpose was not to teach them specific facts, not to train them for a job. I love this line. He said, the purpose was to unsettle their minds. We are going to spend the next 3 hours talking about security. There are going to be some specific facts. There are going to be things that might be useful training for a job you will have someday. But because this is a talk about security, I hope it will unsettle your mind. Unfortunately, security is kind of a big and scary topic. A lot of what I'm going to say today is rattling off lists of things that can go wrong and bad things that people can do to your code. Several times I'm going to tell you, well, you can do this and this and this to mitigate some of it, but there is no perfect solution. There is no perfect protection, which is kind of disappointing and kind of depressing and kind of unsettling. So, a couple points in this presentation, I am going to offer you some comfort. The first and most important thing is this. There is no such thing as secure. Security is not a binary. Security is not an absolute. Security is not something you just have. We're going to talk a lot more about what security means and how it's much more of a spectrum. But just to drive the point home, I had my name and my Twitter handle up there on that first slide. Some of you may have heard of me. Some of you may be here because I'm a committer on the Django web framework, because I have a resume related to Django. The most important thing is I sit on the Django security team. If you find what you think is a security issue in Django, you can email us, security@djangoproject.com. I will be one of the people who reads your email and gets scared at what you found. Django has a reputation, I don't know how we got it, for security, for being a secure web framework, for helping you out with security. We're supposed to be good at this. And do you know what? Since Django was first released, open source, July of 2005 on Bastille Day, we have averaged one disclosed security vulnerability every 66 days. For 12 years. And we're supposed to be good at it. We have a reputation for being good at it. So don't let all of this scare you or get you down or thinking you have an impossible task. Even the people who are supposed to be good at it fail a lot. And later on in this talk, we're going to talk about some of the specific ways we've failed. So there is no such thing as secure. There is no such thing as secure code. There is no such thing as a secure application. Which raises a question of why exactly are we here today? We're not going to talk about how to make your code secure. What we are going to talk about is a few different things. We're going to talk about ways to think and talk about security. We're going to talk a lot about security issues in web applications. We're going to cover some common ones. We're going to cover some uncommon ones. We're going to cover some that I'm just going to have a brief slide or two and pointers off to things you can go look up to learn more. We're going to talk about how to deal with those issues and how, because of our great reputation for security, because we're so good at it, how you can deal with them with Python and Django. And we're going to talk a little bit about the history of Django and security. Remember, we have one vulnerability every 66 days. I'm going to talk about them and how we screwed up and how you can learn from our mistakes and maybe not screw up quite as much as we did. So, security frightens people. Security scares people. Security overwhelms people. They think it's just such this huge thing. How could I ever learn enough, be good enough to deal with this, to handle this? And especially because you run into things like that. Does anybody know what that is? Anybody want to guess? It is not. And I'm not going to repeat that from the microphone recording. The name of a language. No, it is code. That is syntactically valid JavaScript. You can go to this website, type in any JavaScript you like, it will translate it into a form that looks like this. It turns out, because JavaScript is a language. Let's put it that way. JavaScript is an interesting programming language. It turns out anything you can legally syntactically do in JavaScript, you can do with these 6 characters. Open parenthesis, close parenthesis, open bracket, close bracket, plus sign, exclamation mark. Those 6 characters can get you anything in JavaScript. You thought you just had to escape angle brackets. The way this works, by the way, you can read on that site an explanation of how this works, is because of some of JavaScript's type and coercion rules, you can get values that become certain objects and then do things that yield yet more objects by performing operations on them, and then using brackets you can start indexing into them to get characters and digits, and from those you can construct JavaScript. So that's kind of depressing and scary. And of course, we live in the age of the Internet of Things, which Futurama helpfully predicted will end up with greeting cards leading the revolution against us and exterminating all of humanity. And everything today has to be smart, everything today has to be internet connected, everything today has to take pictures of you and listen to what you're saying at all times and send it to a server somewhere doing God knows what. The inevitable result is someone will attempt to hack your pants. This lady, fortunately, is wearing smart pants that are actually smart and are protecting her from being hacked by whatever that guy is supposed to be. I'm still not really sure. But even getting into things that we have to deal with on a daily basis, like SSL. Everybody knows you should have your website running behind SSL, HTTPS, TLS, whatever you want to call it. Pretty soon, in fact, is going to be an even better idea, not just because it protects your users and your data, but because the big three browser vendors other than Microsoft, that's Google, Mozilla, Apple, have all said that they want to either deprecate or loudly flag and warn any site served over plain HTTP in the future. They're already starting to warn on certain forms, and this will get stronger. The problem is all this stuff. This is a guessing game. I'm not going to tell you the answer. You can try and look it up if you want to. Is which of these things below the bottom of the slide are names of SSL vulnerabilities, and which ones are the mind control keywords that turn Bucky Barnes into the Winter Soldier? Give you a couple seconds to make a note there if you want to try and guess. So, security is scary. Security is frightening. Security is depressing. How can we talk about security? How can we begin to approach this? Obviously, it's an important topic. Security is something you have to be aware of. It is something you have to be taking into consideration while you're writing code, while you're designing code, while you're deploying code, while you're using code. You cannot ignore this. Because even if you ignore it, there are people out there who won't ignore it. And if you ignore it, they won't ignore you. We're going to get to an example of that in a minute. But security is not an absolute. Security is not a binary. There is no such thing as secure or insecure. There is no such thing as secure. There are only things whose vulnerabilities have not yet been found and exploited. And there's a lot of potential vulnerabilities. There's a whole lot of things that can go wrong. We're going to talk about a fraction of them in these 3 hours. Which means security is really about trade-offs. And one thing I want to highlight, I saw on the program, There is a talk Friday at 12:10 p.m. in the Portland Ballroom 254 on threat modeling. This is a process that security people go through that really everyone should go through, of thinking about what can go wrong, what sorts of things might people try to do to me, what might they try to do to my company, to my applications, to my code, what are the things they could accomplish, what goals might they have, because that's where your security process has to start. You can't just say, we want to make it secure, because you can't do that, that's impossible. You have to say, we want to be prepared for someone trying to do this. We want to be prepared for someone trying to do that. Security is about identifying which of those things are most important and where you can put your resources to do the most good and give you the most benefit. Of course, the problem is, I sit on Django's security team. I've been on Django's security team for a number of years. I've helped write parts of Django's security policies. I've been the person who gets the email at one point at 1 o'clock in the morning in a hotel room in Denver telling me there was an exploit live in the wild against Django and we needed to get a release out the door as soon as possible. Another story we'll get into more detail later on in this talk is I've been one of the people who got the email saying, by the way, the entire same origin sandbox in all web browsers is broken right now. Just so you know, just a heads up. Security can't be something we just leave to experts. I work for a health insurance company. We serve the Medicare Advantage market. We have a security team. People whose job specifically is to be security engineers to help us think and talk and plan around security, ways that things could go wrong, ways we can prevent, ways we can protect. But it is everybody's job. It's not just, oh, we'll throw this at the security engineering team and see what they say. It's something that every single one of us, every single one of you, and every person you work with needs to be thinking about. Because this is not just something for experts. You don't need to be a security engineer. You don't need to be a security expert. You don't need to have written books about this stuff. You can contribute. You can learn things. You can think about this stuff. You can integrate it into your development process, your design process, and be thinking about it all the way through, which you have to do, because you cannot treat security as an afterthought. You cannot say, oh, we'll deal with that later. You cannot say, oh, we didn't have time for it, or oh, that'll be a follow-up project. So I wanted to give an example. Did anybody see this a little while back? This was in March. This is a quote from a bug report posted to the Mozilla bug tracker. Mozilla has introduced a policy in Firefox that if you serve a login form over plain HTTP, no encryption, it will put a warning up there saying the form is insecure. Other browsers will do this too. Chrome will do it. I believe Safari does it now. This company called Oil and Gas International was very upset that Firefox was displaying a security warning. And they said, your notice of insecure password automatically appearing on the login for our website is not wanted and was put there without our permission. We have our own security system and it has never been breached in 15 years. Anybody want to guess how that turned out? So, that bug report was filed publicly. Somebody tweeted about it. It showed up on Reddit, a couple other places. Got a lot of public attention. Not only were they not using SSL, they had web-based debug and stack traces enabled on their ASP.NET application. They had a SQL injection vulnerability. And it turned out, once people started exploiting the SQL injection vulnerability, they were storing user account details, including passwords, in plain text in their database. The site was compromised and offline a couple hours after they posted that bug report. Some people in the Reddit thread suggested that was actually a mercy and that someone had done them a favor. The reason it went down was someone dropped their accounts table. Just completely dropped it, deleted it. And people suggested that was actually a good thing because they were storing account details, plain text, anybody could get at them. And somebody said, well, that's actually maybe the ethical thing to get that data off the internet as quickly as possible. There are a couple good blog posts written about this. Troy Hunt, who's a great security blogger, had one. You can just dig around, just type oil and gas international security bug. You'll run into it. But that's a good example of why you have to be thinking about this. You have to be prioritizing this. They ignored a lot of things about security, but security did not ignore them. And that's unfortunate. And probably people got their data compromised as a result of this. There are real-world consequences. Like I said, I work at a healthcare company, so it's sort of closer and more at the front of my mind. Because if I screw up with security, number one, it's a federal legal matter because federal healthcare privacy laws, but also it's people's healthcare data that could get compromised. And that's one of the worst possible things to have get out there about you. Yep?
They had stack traces that would show up in web pages?
Yeah, they had, just like Django has a debug page.
Yes, they just didn't turn that off.
Yeah, they had full stack traces showing up on server errors. ASP.NET will do that very similar to what Django does with its debug page, and they just left that turned on. So you have to think about this stuff. But what should we think about? What sorts of things do we need to know about? Let's start with some popular ones. The OWASP Top 10 list. OWASP is the Open Web Application Security Project. They publish every couple of years a list of the top 10 most common, most important vulnerabilities they see in web applications. There's a link to it. I believe the most recent edition is from a couple of years ago. I've heard rumblings of a new version coming out that may be a little controversial. We're going to cover what's up there right now unless they've already gone ahead and published a new version while I wasn't looking. So, number one. Injection attacks. I mentioned that site had a SQL injection attack. Is anybody just trying to gauge the level here? Who has heard of SQL injection? I like you. So who can tell me what's wrong with this code? Imagine you were writing this in your Django application and for some reason you weren't using the Django ORM to do your database queries. Yeah.
Allowing the string without any checks on
Yeah.
parental checks.
Yep. We are interpolating a string directly into a SQL query. And that's a problem. Now, why is that a problem? We're reading a username out of the query string parameters. Query string parameters are under the user's control. They can send anything they want. Well, what happens if they send us that? The answer is bad things happen if they send us that, because we will drop that into our query. And this is a fairly common pattern. We're going to have our quotes and a semicolon to terminate the query that I actually wrote, and then another query that makes our hacker into an admin in our database and gives them a nice little account where they can do anything they want to. Now, SQL injection is not the only form of injection attack. In fact, there are a lot of them. There are mail header injection attacks. Has anybody ever looked at their web server logs and seen a lot of requests for formmail.pl over and over and over and over and over again? Contact forms, anything that sends email based on a web request, is a vulnerability because email is a really old protocol and it uses headers which are separated by new lines. So suppose, for example, you have a contact form, you have a field for someone to enter their address, which becomes the from address on the email you're going to send, and I put in a value with my email address and then a new line and then maybe a CC or a BCC header with a list of addresses. If you're not paying attention to that and you just accept that as is, email is a plain text protocol. Headers are separated by new lines. I've just injected a list of CC or BCC addresses into the email you're going to send. Now I can use your contact form to spam people. Command injection. This was actually the very first vulnerability Django ever publicly had and disclosed, was a command injection attack. Anytime you have something that's kicking off shell commands or scripts on your server, you may be passing parameters and command line arguments. We can do the same thing. If I can control what gets passed to that, I can escape out of whatever command you wanted to run and start running whatever command I want to run. Then there's XML injection attacks. XML processing is really, really hard. I don't think there is any tool chain out there that correctly processes XML according to all the specs. And even if it did, I'm not sure it's a good idea because XML allows you to do some things that probably are not safe. The traditional attack here is what's called the billion laughs attack, if anybody's heard that phrase before. Have you ever worked with HTML entities where you do that, ampersand and then the name of a character and a semicolon to do like special characters? Those are entities. HTML is based on SGML, which allows you to define custom entities. XML lets you do the same thing. The idea is you can define custom entities that do all sorts of things. Maybe they expand to gigantic size and consume all the memory. Maybe you load entity definitions which just happen to be stored in your system password file. You can make an XML processor read arbitrary files and in some cases even read arbitrary URLs and load what's in them. So basically anything that takes user input and takes some action based on that input is a potential vector for an injection attack. So that wasn't scary enough. Problem number 2 on the top 10 list is authentication and session management. Yes? Yes, the slides will be available online after this talk is done. It's also being recorded by the gentleman back here. So there will be video as well. So authentication and session management. We like having users. We like them being able to log in. We like being able to know who they are. We can screw that up pretty badly. There are a lot of things that can go wrong here. Some of them overlap with other issues on this list, like storing them in an insecure way or a less secure way, transmitting credentials over an unencrypted connection. That's the thing the browsers warn you about. That's the thing Oil and Gas International complained that they were being warned about. Allowing people to reset or overwrite credentials too easily. Have you ever gotten a password reset email that you didn't ask for? It's kind of a frightening experience, isn't it? You wonder who's trying to get into my account. It can be very easy to get into an account that way. Exposing any kind of identifier, especially a session identifier. Every once in a while, I have to visit a site that does one of those JSP URLs with a session ID in the query string, and it frightens me every single time because I know that's my session ID and it's in the URL and possibly even being sent in plain text. Session hijacking and session fixation are kind of fun. Hijacking is where someone can take over your session, or fixation is where someone can force the use of a particular session, with all the bad things that that entails. Next up on the list is cross-site scripting. Everybody, y'all heard of SQL injection? Have you heard of cross-site scripting? So who wants to take a guess at what's wrong with this bit of code where we're not using the Django templating system for some reason? We've just decided to construct HTML randomly. So we had a problem before where we read a name out of a query string and put it in a query. Now we're putting it directly into HTML.
So you could substitute, well, you could put JavaScript in the get parameter query string, and then the JavaScript will basically get that over there and then spit out everything.
Yep. Yep. Once again, this query string value is under the control of the person making the request. They can put anything in there. And what happens if they put something like this in there? Well, that's JavaScript. That's going to end up in the page that you serve back to them, and it's going to execute. Cross-site scripting is a really scary thing because it means someone can execute arbitrary JavaScript in the context of your application. And JavaScript can do lots of bad things. We're going to see what some of those are in a little bit. Next one up is insecure direct object reference. This one is kind of an arcane wording to describe it. But to give an example of what it looks like is, suppose I go to a site and I see a URL like that. And I say, well, I wonder what happens if I change the number. I wonder what happens if I change the number again. Now this is usually most exploitable in combination with some type of access control failure, like letting me see things that maybe I wasn't supposed to see. But even just this can give away information you didn't want to give away. Real life example. Has anybody heard of the German tank problem in statistics? This came out of World War II, where the Allied forces were fighting Germany and Europe, and they would occasionally capture a German tank, and they would take them apart and look at the serial numbers of the components, which were sequential. They estimated, based on looking at those serial numbers, that Germany was producing 270 tanks a month. After the war, they captured factory records. They estimated 270, it was 276. Someone who can get access to a bunch of identifiers, especially if they're sequential, can start figuring out things you maybe didn't think they could figure out about what's going on in your application, what kind of data you have, what's available. I will say right now, there's a temptation to solve this through non-sequential identifiers or through random identifiers. This is what you'll hear referred to sometimes as security through obscurity, which is trying to hide the problem rather than solve the problem. We would like to solve the problem. I'll mention some examples later of how you can do this with Django, but the goal here is not make the identifier hard to guess things about. The goal is don't let people see your internal identifiers. Next one up is misconfiguration. This one, anybody remember the Mirai botnet, which Toyota has unfortunately come out with a new, I believe, hydrogen fuel cell car called the Toyota Mirai. Apparently they didn't know what else that was named. Mirai was a botnet that infected over 1 million devices, cameras, baby monitors, things like that, because they all had default usernames and passwords set at the factory. And the moment you plugged them into an internet connection, anything could connect to them with that username and password. So a lot of places you should probably check on. Any default accounts or credentials or authentication bypasses. Sometimes things even have like a backdoor built in that's supposed to be only for the administrator on the local network. Well, we know how well that works out sometimes. Any debugging modes, like that stack trace that Oil and Gas International showed, or the Django debug page, or the Django debug toolbar, if anybody uses that. Any security settings for software you're using, any error handling behaviors can expose things. The Mirai botnet, at its height, the estimate now, I have it mentioned here, is 1.2 million devices were infected. And it was so bad that even if you rebooted and reset one of those devices, by the time you could get it turned back on and log in to change the credentials, it would be infected again. Someone on the internet, anonymously, I don't know what the name is behind their username, described this as, "We built the internet to be resistant to a nuclear war, and over the past couple years we've made it vulnerable to our toasters." Because Mirai took down Dyn, D-Y-N, which is one of the biggest DNS providers in the world. They provide DNS for a lot of major websites, and they were the subject of a denial of service attack launched by the Mirai botnet. Next problem OWASP wants us to know about is sensitive data exposure. This one is big This one is scary. This one, there's no way to cover even half of the things that can go wrong. But here are some ideas. Anything you do which transmits or stores information, not just your database. What about your log files? Your server is logging every request. Django has a logging framework. Django may even be generating logging events that you're not aware of. Just this morning, in fact, as I woke up, I saw an email to one of the, or not an email, a post on the Django subreddit asking about how to ignore certain logging events coming out of Django. Error handlers. Who here uses something like New Relic or another monitoring service that gets a report on every single request you serve? How are you transmitting information to them? What information are you transmitting to them? And of course, we have credentials. I'm going to say over and over and over again, anytime credentials are transmitted, do it over a secure connection. Missing function level access control. This one by itself is bad. It gets worse in combination with other things. Django can help you with this. We'll talk about specific techniques later on. But every single function in your code which can modify data, create, delete, change, whatever, must be protected. Must be protected by authentication and authorization. Is everybody sort of familiar with the difference between authentication and authorization? So they are two different things, and it's an important distinction. Authentication is who are you. Authorization is what are you allowed to do. Simply requiring authentication is not enough. That means you know who deleted everything. You also probably want to make a list of who's allowed to delete things and control that. Cross-site request forgery. This one's especially fun. CSRF attacks, I don't have a good example of one because they're kind of tricky to set up. CSRF attack is basically someone who is a legitimate user of your application, probably logged in, they have an active session, they're someone who's allowed to maybe delete everything in the database, is deceived or tricked into sending a request to delete everything in the database, or modify data, or take some type of action that they didn't intend to take. The easiest way to get to a cross-site request vulnerability sometimes is a cross-site scripting vulnerability, but there are a lot of other ways to do it. And there are components with known vulnerabilities. Everybody been reading the news this week? Reading about the WannaCry, WannaCrypt ransomware that's infecting everything everywhere this week, encrypting people's hard drives and demanding bitcoins. There's some political aspects to the story, but one of the important things is it infects unpatched versions of Windows. The patch for this, I'm told, came out in March. This is May. People went 2 months without applying a critical security update, and now their hard drives are getting encrypted. Unfortunately, this is hard. Especially large organizations can't always quickly do an upgrade or quickly roll out a patch or a security update. Sometimes it's not even possible to keep track of everything you're using. I mean, just that can be a job that's too difficult. But any issue, anywhere, in any piece of software you're using can compromise your whole stack, as people unfortunately learn over and over again. Finally, unvalidated redirects and forwards. This is another one of those sort of obscure wordings. So we'll go to an example. This is something that you'll see a lot in Django, is log in with a next parameter saying where to go after they've successfully logged in. Well, I wonder what happens if I pass that as my parameter to go to next. You can end up sending a user to places that maybe you didn't expect them to go, especially if someone manages to get them to click on that link without realizing what it is. This is a common way people do phishing scams, is they'll find something that does redirects and allows specifying the URL to redirect to, and it'll be a site the user trusts. And they'll email them a link saying, click here to do this important thing on the site. and they end up on a completely different site because of that redirect. So that's the OWASP top 10 list. Everybody feeling scared? Everybody feeling like maybe bad things could happen? Everybody want to maybe learn, well, what can we do about it? Let's talk about what we can do about it. That, by the way, is a quote from a coworker of mine. He was complaining about time zones, which are one of the things that's harder than security. Let's talk about injection attacks. How do we deal with an injection attack? We often do need to construct, say, a SQL query using input from a user. How do we do this safely? Here's what it looks like in SQL. The big difference here is we're still using this formatting placeholder, but now we're calling the query this way. So what's called a parameterized query. We are giving the database two things. Instead of just sending it a query, we're sending it a query with some placeholders and a list of the parameters that go into the query. All the databases that Django supports understand this. The exact placeholder syntax varies a little bit. Django ORM knows how to handle this for you. Then the database will safely combine the parameters and the query in the correct placeholders. So if you're using the Django ORM, most of the time you don't need to worry about this. You are protected by default because we use parameterized queries by default. However, there are places in Django where you can supply raw SQL or clauses of a raw SQL query to the ORM and have it executed. It's the extra method on a query set, the raw method on a query set, and the raw SQL query expression all let you do this. All three of them are built for parameterized queries. You can pass in a fragment of SQL with placeholders and an extra argument with the parameters, and Django will turn that into a properly parameterized query. Please, if you're using these features, do that. Now, we mentioned there are some other injection attacks. Mail header injection is where you have new lines, and that supplies extra headers to an email that maybe sends it places you didn't expect it to go. Django will protect you against this by default. Django has an email sending framework built in. When you pass an email message to Django, if it notices new lines in values that are supposed to be headers, it will immediately raise an uncaught exception, bad header error, and it will refuse to send the email. Also a thing to be aware of, if you're writing code that uses Django's email sending functions and you're handling user input, you will probably want to watch out for that bad header error exception and catch it and log what happened. Command injection, anytime you're using Python's ability to shell out to other commands. Hopefully you're using the subprocess module, which makes it a lot easier to do this. Never, ever, ever use the shell equals true argument in a subprocess call. That will expose you to command injections. XML injection is really, really hard to stop. I wish I could tell you that there's an easy, comprehensive solution. There isn't. The best thing you can do by default is there's a set of libraries called defused XML. These replace and patch Python's own built-in XML processing libraries from the standard library and do their best to fix them to solve some common XML injection vulnerabilities. Django actually issued a security advisory a few years back recommending everyone run out and get and use these. So what about authentication and session management? Well, we have that in Django. We have an authentication framework in Django. We try very hard to make that authentication framework be, I won't say good, because I don't think there is a good authentication framework out there, but to make it as good as we can and to make it safe for you. Django implements a lot of the tricky bits in authentication for you and implements them in ways that have been vetted and in some cases found to be bad and then fixed by hundreds of thousands of people over the course of 12 years. Django handles password storage in a way that we think is about as best as we can manage out of the box. Django handles password resets in a way that's about as good as we think we can handle out of the box. Django's authentication framework also handles some things we haven't gotten to yet. However, there are still things you can do. Number one, most important, how many times I'm going to say this, serve your site over a secure connection. Turn on HSTS, which is something we're going to talk about in a little bit. Mark your cookies secure, make them inaccessible to JavaScript. We're going to talk about how to do that. Never, ever, ever, ever expose a session ID in a query string like JSP does. Use the password validation system, which was new as of Django 1.9. Django can now gauge password strength and reject things like common dictionary words or very weak passwords for you automatically out of the box. In fact, if you start a new Django-based project and do manage.py create superuser and try to type in a common or very weak password, it will refuse to accept it. You can also set some length requirements and other things. Cross-site scripting. We're going to come back to this one over and over again. But the most important thing is that by default, Django applies HTML escaping to every single variable you output in a template. You do still need to audit everything else. You do still need to do some other things that we'll cover in a bit. You do still need to be watching out for unsafe things. Special mention here to inner HTML, JavaScript. Never ever use that, please. Please never use that. One other important note, JavaScript does have a template filter called escape.js. That's a really bad name, and I wish we could change it because it doesn't do what you think it does. Escape.js does not make JavaScript safe. Escape.js puts backslashes in a string to make it be syntactically valid JavaScript, which is actually the opposite of what you would want an escape.js function to do. I don't know why we named it that. Insecure direct object references. I mentioned this one is tricky because it's tempting to just use random identifiers and keep exposing them. The real solution here is don't expose your internal identifiers. Use what's called a natural key. Lots of things have a natural key to refer to them by. For example, instead of the ID of a user account, how about put the username of the user account in the URL? We can still run through a lot of common usernames and guess how many there are, but we've made it a little bit harder, and we haven't exposed our internal identifier, which means somebody who found a way to access things we didn't want them to wouldn't have a list of our internal identifiers to use against us. Yeah. HIPAA is really, really hard. Is there a HIPAA compliant identifier? The answer is I don't know of any general purpose HIPAA compliant identifier. It's a thing that at work we've gone multiple rounds about, well, what sort of identifiers do we use? How do we handle them in our applications? How do we pass them around? Which identifiers are protected health information for the purposes of HIPAA? Which identifiers aren't? Yeah, it's HIPAA is scary. We can talk more about that if you want to swap some more stories. So, yeah. Is it enough to just hash the name? I still feel like you're just obfuscating the identifier rather than getting rid of handing out the identifier. The solution really is stop handing out your internal identifiers.
You're not saying hash the identifier, you're saying hash the you take Jane Doe and then
Off the top of my head, I don't know. I suspect it wouldn't be compliant, but I've been surprised at what's allowed before. So, misconfiguration. This is one Django can help you with a little bit. Django has a system check framework, the manage.py check command. Very important one is the deployment check, which runs a subset of the checks looking for things like, do you have debug on? Do you have the allowed host? I think it checks the allowed host setting. I think it checks a few other things. It's looking for common misconfigurations that you don't want to have when you're about to take your application into production. There's also a subset that are specifically security related that will check your Django configuration for you, and you can run them with check -- tag security. So sensitive data exposure. This one is fun and this one is scary. Passwords and other credentials are the big one here. Django's authentication framework, the default user model that comes with it, does store usernames and passwords in the database. By default, we use PBKDF2 as our key derivation algorithm for storing passwords. We raised the number of iterations every time. We had to do it a little bit slowly because older versions of Python didn't have a fast implementation of PBKDF2 built in. You can also use Argon 2 and bcrypt, which are sort of widely recommended, popular key derivation algorithms, hash functions, for storing passwords. In fact, we make it really easy. When you pip install Django, you can put these brackets after the name and ask for Django to install the appropriate libraries alongside, and then the documentation will tell you what to configure after that. Does anybody know why we prefer these algorithms over something like SHA-1 or MD5? There's an important point here. If I get, yeah.
They are slower, which means very little when you're doing it once, but you do a lot when you're trying to report.
They are slower. Yeah. Collisions are a problem. The main thing we're looking for here, though, is that they're slower. And especially the fact that we can tune how slow they are. PBKDF2 and bcrypt, you can tune how long it takes, how many iterations are being done. Because the common thing people do when they get a bunch of password hashes is try and figure out what are they by brute forcing or running against a table of common passwords and generating a bunch of hashes to see what they would be. Try and figure out what are those hashes, what values produced them. If we can make that process slow, we can make it much harder. Argon 2 goes a step further. Not only can you make it take a lot of iterations, you can also tune it to use more memory and to defeat some types of parallelism, which unfortunately we have to do because we live in the age of bitcoins, when people build specialized rigs designed to calculate lots of hashes very, very, very quickly and in parallel. Hash functions, hopefully using one of these will be good enough for a little while. If it ever isn't, Django will try and change it. Django also provides some tools to let you say what is sensitive, what needs to not be exposed in my application. Obviously, you don't want to expose anything, but there are certain things that are especially sensitive. You can mark any Django view with these decorators, which let you pass a list of either variables that will be local inside that view or parameters will be coming in from the request that need to be treated as especially sensitive. It's going to look like this. And what's going to happen is, in this view, if there is any error, any exception raised that is not caught, Django, if debug equals true, will show you a debugging page with stack trace. Django will log an error. It will invoke whatever error handlers you've configured, whatever logging you've configured. Ordinarily, it would show you a lot of information. If there's an error inside this view, Django will scrub out the values of those variables as it's doing that. So the username and password will not be visible in anything that Django logs for you. We also do this by default with certain parameters. Anything containing API, secret, or key automatically gets this scrubbing treatment whether you ask for it or not. Sometimes it might be frustrating, but better safe than sorry. The problem here is, you'll notice this is called sensitive post parameters. What about get? Well, you should really try to keep get parameters from ever being sensitive, because lots and lots of things will log get parameters. Some of them may not even be part of your stack. They may be downstream caches or proxies will have this in their logging and they will know what was sent. So as much as possible, try to avoid ever having sensitive parameters in GET requests. So missing function level access control. This is another thing we can do. Django provides you with tools for this. There are two sets of these. One set for function-based views, one set for class-based views. For function-based views, we use a decorator. There are three of them. Login required says anybody who's logged in can hit this. Permission required will say anybody who's logged in and their account has this permission set on it. User passes test is the generic catch-all. When you apply this, you give it a function which takes a user and returns true or false. True means they're allowed to do this, false means they're not. So you can supply any arbitrary Boolean check you want in there. If you're using class-based views, there are mix-ins for this. There's a login required mix-in, a permission required mix-in, and a user passes test mix-in, which do exactly the same thing. You can also tell Django to only allow certain HTTP methods. This can be important because you might have a view that you're thinking would only be called with post or is only going to be called with get, and people might try to see, well, what happens if I don't do that? So there is a set of decorators, require get, require post, require HTTP methods, lets you specify a list of methods. Require safe is a shortcut for only allow get and head, which are defined by HTTP to be the safe methods because they are not supposed to change data. Anyone hitting one of these views without the correct method will automatically get an HTTP 405 method not allowed. On a class-based view, you don't use a decorator. Instead, if you're using Django's generic class-based views, you can set the attribute HTTP method names to a list. Looks like this. So that view will only allow post and put requests. You can also dive in a lot deeper and put custom logic in your view to have per object control. You can override on generic views how they do their query set, what they're willing to fetch. You can do permission checks there if you want to. And anywhere in any code you write, you can raise the exception django.core.exceptions.permission denied. If you raise that exception and it gets up to Django's response handler, Django will turn that into an HTTP 403 forbidden, which is a useful thing to know. It's cross-site request forgery. This one is complex. There is CSRF protection in Django. It is on by default. Please don't turn it off. The thing you need to know is if you're using the Django template system, anytime you have a form tag that's going to use an unsafe HTTP method, which is anything other than get or head, put the CSRF token just after the opening form tag. We provide a template tag for that in the Django template language. We also provide a template variable for it in the Jinja backend. If you're doing AJAX, it is a little bit more complicated. You can go read the documentation for the CSRF framework and see how to do that. How we handle that has had to evolve a bit over time, and I'll mention an example of why in a little bit when we get into failures in Django. Components with known vulnerabilities. This one is really, really, really hard. Like I said, you don't always even know everything that you're using. If you pip install something, do you actually know before you do that the full list of dependencies that's going to be installed as a result of running pip install? There are ways you can freeze the entire list, and in fact, there are ways you can control exactly what gets installed. But this is something Django can't really directly help you with, because Django itself doesn't know what other software you're using. I don't even know sometimes all the software I'm using. I don't expect Django to figure it out. But there are some things you can do. For Django itself, we have a mailing list called Django Announce. It's run on Google Groups, just like Django users, Django developers. It is only used to announce new Django releases, including security-related releases. You should be regularly running package updates, operating system and Python packages as well. I really, really recommend requires.io. There are a couple other services out there like it. Requires.io is free for open source projects. You point them at your pip requirements file, and they keep track for you of which versions or which software is mentioned in your requirements file that's out of date, and they also show a nice little red warning label on anything that has a known security vulnerability. Monitoring that gives you a leg up on figuring out when you need to upgrade. Also gives you a full list of everything you're using, which may be hard to figure out sometimes. Unvalidated redirects and forwards are really, really difficult. The official advice I will give you, and Django does not follow this advice, is don't rely on a user-controlled parameter to determine where to redirect. It's a really bad idea. When we get to this later in the Django failures section, I'm going to ask you how many times you think we've had vulnerabilities in Django as a result of doing this. So start thinking about that right now, and please don't cheat and look it up. If you do need to rely on something from a user to determine where to redirect, there is this function, django.utils.http.isSafeURL. It can help you, but it is not perfect. It's debatable whether it even does a particularly good job. It does about the best job we can make it do right now. But the last time we had a vulnerability reported related to isSafeURL, which was just a couple months ago, this conversation happened in the Django committers IRC channel. One of the other committers later said, putting safe and URL in the same function name is a bit like putting cesium and stable together. So, what can you do? Use isSafeURL, but if at all possible, try not to actually need it. Try not to issue redirects based on a user-controlled parameter. So we are just about halfway through, and we are just about at where the break begins. I can probably get a few more slides here, like maybe one more subsection. Do you all want to do that, or do you want to start the break now? Anybody? Keep going? Okay, so I've been saying over and over and over and over and over again, use SSL, use secure connections. Do this, please, please, please do this. One of my projects right now is for my own dinky little personal blog that I never particularly cared about. I'm going to set up SSL for my personal blog because it's that important and because I want to be setting a good example. But there's a problem here. Can we make people use secure connections when we offer them? Yes, we can. You can force redirect users coming to your site when they make a request over plain HTTP. You can redirect them to the HTTPS version. Turn on security middleware. Security middleware is going to get a lot of attention in this section because security middleware is really cool, and I like it a lot. Toggle this setting on. Everybody will be redirected to the HTTPS version of your site. But there's still a problem with this. Problem is they made an HTTP unencrypted insecure request to begin with. Can we stop that from happening? And the answer is the very first request they ever make in the history of their interaction with you, probably we can't stop it. But we can stop it after that. No matter what they bookmark, no matter what URL they visit, we can tell their browser, remember, use HTTPS. HTTP strict transport security. We send a header out on all of our HTTP responses telling the browser we always want to be accessed over HTTPS. This does come with some conditions. You have to make sure everything on your site, not just the URL of the page you're serving, every image, every style sheet, every script, every media asset, every web font, everything that is requested by that page must be served over a secure connection, or else the browser will refuse to connect and display it. Security middleware lets you do this. The value I have there sets an HSTS header with a value of 1 year. That's what you should go for eventually. When you first start turning this on, you should set that value much lower. It is specified in seconds. The reason why you should set it much lower is because if there is a violation of HSTS, if you discover something in one of your pages that's not being served over a secure connection, not only will the browser refuse to show the page, it will remember the violation for that many seconds and refuse to connect for that long. You don't want to lock yourself out of your own site for a year. Set it low to begin with. If you do accidentally lock yourself out, most browsers have a way to clear the HSTS cache. You can Google for that. There are Stack Overflow answers telling you how to do it. But start off with a low timeout. Make sure everything is good, and then turn it up. Yeah? There is no default that I'm aware of. By default, HSTS isn't on. It's when you turn it on, the header requires a value, and the way you turn it on in Django is by setting the number of seconds. Yeah, yeah. The other thing there is the include subdomains setting, which tells the browser not just the top-level domain of my site, but this applies to every subdomain of my site. Must be accessed over a secure connection. Yes?
Can you apply that to the subdomains, or does that apply to the top level? So if I set it up as foo.bar.com, will it apply to all bar.com, or can I set it?
Off the top of my head, I don't remember. He's asking if I only set it on if I only send that on a subdomain, will it apply to the top-level domain? Off the top of my head, I don't remember. I would suspect it only applies to the subdomain you sent it from in that case, but I would say go look up HSTS. Mozilla Developer Network has a really good article about it. And I'm not just biased because I used to work on that, but MDN has a good article about it. So who's heard of content sniffing? Content sniffing is a fun one. Content sniffing is a feature of web browsers where rather than paying attention to the content type header you send, they just read the first sometimes 512 bytes, sometimes a little more, and guess what they think the content type is. That's a problem. That's a problem because it's very easy to make a file that looks like one thing but actually is another. You can hide all sorts of things in the headers of image files. You can hide JavaScript in the headers of image files. People have done this with real image files. How can we stop a browser from doing this? Hey, it's security middleware again. You can send a header, X content type no sniff, which tells browsers, hey, I know you think that's a feature and it's a good thing, but I really wish you wouldn't do it. And browsers will respect that. And browsers will stop trying to sniff your content and guess what type it is. And this will shut off some issues you can have, especially if you're accepting user-uploaded content, though there are other things you should do as well. We are at, let's see, about 5 minutes to go. I think we can get another section in. So let's talk about cookies. Everybody likes cookies, right? Everybody seen those warnings anytime you access a site in Europe that tells you, EU cookie notice, this site uses cookies to offer you the best experience. Or when you're accessing anything anywhere else in the world, it says, this site uses cookies to offer you the best experience. Turn them on or we won't show you a page. Cookies are really useful. However, JavaScript can access them, and anything JavaScript can access is dangerous. And browsers will send them on secure and on insecure connections. And that's a problem because cookies contain things like your session identifier, and sometimes even your session data, which means that people who have bad intentions can get access to that data. This is not security middleware. This is built into Django. The CSRF framework uses a cookie. The session framework by default uses a cookie. You can turn on these two settings and tell Django those cookies need to have the secure flag set, which means they are only sent on HTTPS requests. They are never sent on unencrypted plain HTTP requests. That gives you a little bit of protection. Another thing you can do is set the HTTP only flag. This does not mean plain HTTP. This means these cookies are only accessible in HTTP requests. JavaScript is not allowed to touch these cookies. Now, HTTP only is tricky. It's a thing that I will recommend you turn on unless you have a really, really good reason for JavaScript to be accessing these cookies. But it is not perfect. It is not a real solution to JavaScript issues. We're going to talk more about those in a few minutes. At best, it is one small part of a multifaceted strategy for protecting yourself from the evil that is JavaScript. So turn it on, but don't think of it as a perfect solution. So what can we do with frames? Anybody used HTML frames or iframes before? Back in the 90s, we used to do this all the time. Everything went in a frame. Well, turns out you can do bad things. Clickjacking is a fun attack. This is where I show you a page with a button like, click here to claim your free iPhone. Except on top of it, I have overlaid an invisible iframe containing some other website. And I've lined up some important button from that website just over the thing that says click here. So when you click there, you're actually sending a request to some other website to maybe delete some data or grant access or take any kind of action that you probably didn't want to take. How can we stop this? Frames are bad, frames are evil. Back in the 90s, we used to have frame-busting JavaScript that would try to detect when a page was being displayed in a frame and break out of it. Now we have the X-frame options HTTP header. Security middleware is my favorite thing in Django. You can turn on this header. It has a couple different values. If you set X-frame options deny, this means that your site is never allowed to be displayed in a frame or an iframe ever for any reason anywhere. Browsers respect this and will refuse to frame your site. If you set X-frame options same origin, browsers will apply same origin rules to the framing. Your site will be allowed to frame itself. Other sites will not be allowed to frame you. I highly recommend setting deny unless you have a really, really good reason for needing to frame your own site. And if you have a good reason for needing to frame your own site, you have my sympathy. So we are right about at break time, so let's pause here. And I believe there will be some refreshments out in the lobby. And then when we come back, we will have the second half. Anybody have any questions or anything they want to talk about before we go? Yeah.
That was really interesting with the middleware piece. Do you have like a linter or like an app scan that would go through IDE to check for these things for like helping out security for developers?
Yeah, the manage.pycheck command that I mentioned earlier, you can run that. You can also plug in your own checks, and you can raise warnings or errors out of that. So yeah, if you want to write your own custom checks to make sure you've configured things the way you expect them to be, and maybe even make that part of an automated testing process, you can use manage.pycheck and plug in custom checks that you want to run on your code to make sure you've configured it the way you expect to. Let's get started. So, JavaScript. Have I mentioned JavaScript is evil? No offense to people who write JavaScript. Many of them are good people. But JavaScript is such a headache. We mentioned Django will auto-escape variables and templates for you. This is one step towards dealing with potential cross-site scripting. But, remember this? That's JavaScript. That's valid. That's syntactically legal. We're going to need something more than just escaping output. Another thing you can do. Have I mentioned I love security middleware? Because I love security middleware. You can set this. This one is going to be controversial, and this one may get some people on Twitter yelling at me for recommending this. But most browsers now have a built-in auditor or detector for common signs of cross-site scripting attacks, which you can enable with an HTTP header. Each browser has its own different approach. The different filters behave differently. There is a history of bugs which bypass these filters. What's supposed to happen when you set this is the browser's cross-site scripting auditor is turned on. If it notices something it thinks is a sign of a cross-site scripting attack, it will refuse to display the page and refuse to execute any JavaScript. There are several values for the underlying HTTP header. The only one that is even close to possibly being safe is the one that gets set by doing this. It sets the value 1 mode equals block, which is the one that Django turns on for you. However, this is not enough by itself. There have been bugs, there have been bypasses in this, and browser vendors do not always consider bugs in the cross-site scripting filter to be security issues. I believe Google Chrome has an official policy regarding that they don't treat them maybe as seriously as you would think they would with a cross-site scripting bypass, because it's not a thing you're supposed to rely on by itself. You'll notice a theme here. Protecting yourself from JavaScript requires a lot of work. What you would really like to do, what you would really love to do, is say, here's the JavaScript I want to run, don't allow anything else. Wouldn't it be nice if we could do that? We can sort of do that. Content security policy. Once again, is an HTTP header. This is a theme. Lots of things that were not built into HTML or HTTP or the other protocols until it was too late and we discovered, oh crap, everything is broken, have been sort of bolted on in the form of HTTP headers. Content security policy is a header that lets you specify allowed sources for JavaScript, style sheets, images, fonts, all these things that are potential vectors for badness to happen. If you set a content security policy header and a browser encounters an attempt to load something not permitted by the header, it will refuse to load it. If you disallow inline JavaScript in the HTML, which you can do with CSP, the browser will refuse to execute that JavaScript when it encounters it. So now you're asking, how can I do this in Django? Does security middleware do it? No. Unfortunately, security middleware does not. However, there is a package called Django CSP maintained by Mozilla. Provides configurable CSP support. There are 2 published versions of CSP. There's CSP1, CSP2. There's work going on for a CSP3. You'll want to read a little bit about how to do this. And setting up a good content security policy can be tricky, especially if you work in a company that has a marketing department that likes to keep adding trackers and A/B testing and metrics and analytics in your pages, which all use JavaScript from different domains. To make CSP work, you have to be able to specify upfront every domain you will load things from, which can be tricky, but is worth it. Now, there is another problem. We mentioned content sniffing earlier, that somebody could maybe upload a file that is an image, but the first 512 bytes of it pretend to be JavaScript to trick a browser. Users can upload anything, images, any type of file, and have you serve those. You are at risk because they can do evil things in those files. A really important thing you can do that doesn't involve any Django settings is serve that stuff from a different domain. Have you ever noticed that GitHub has its GitHub Pages feature, which lives on the domain github.io rather than the domain github.com? It's because being on the same domain to a browser enables so many bad things that you don't want to have happen, like access to cookies, like being able to do JavaScript and make same origin requests. Get a CDN, or if you don't have a CDN, just set up a server with static files on it and put a different domain name in front of it, a completely different top-level domain name, and serve that stuff from it. Because if you serve it from the same top-level domain, or if you serve it from a subdomain of your top-level domain, you're gonna be at risk of some problems the moment you let somebody upload something. So like I said, this is hard. Fighting JavaScript is difficult. There is no perfect solution. There is no single thing you can turn on or do that will protect you. Instead, you need to use lots of different things all working together so that when one of them falls down, the other ones are still there protecting you. And this is a thing that's true over and over again in security. There is no silver bullet. There is no magic thing you can do other than just give up and become a potato farmer. But JavaScript is a gigantic threat. It's also a useful language. It can do a lot of cool things. But today, JavaScript is the enemy. In this tutorial, JavaScript is the thing we want to avoid. And avoiding it requires a lot of work. Speaking of JavaScript, so I mentioned JavaScript has that same origin sandbox. By default, you do JavaScript, you want to do, like, say, some AJAX requests. JavaScript in the browser has this policy that you have to stay on the same domain. You can override that. It's not always a good idea to override that, but you can. Standard called CORS, Cross-Origin Resource Sharing. You can set this via, anybody want to guess how you do this? What's the mechanism for it? It's an HTTP header. So you can override this and tell a browser it's okay to load things cross-domain. Override the same origin sandbox. There are times when browsers accidentally do that. I said I would tell this story when I got to this slide. Back in 2011, the Django security team got an email. Turns out, I think it was someone at Google discovered this and reported it to Rails, and then it got reported to us because we had the same issue. We were trusting the browsers. We're trusting the browsers to enforce their own same origin policies on XML HTTP request, AJAX. Turned out that was a bad idea because a combination of bugs in the Flash Player plugin and the way browsers behaved on an obscure HTTP redirect code. Raise your hand if you know what HTTP 307 does. I didn't until I got this email. Allowed you to do cross-domain requests with custom headers on them, which let you fake out our CSRF protection system. Because at the time, it was relying on AJAX to set a custom header because browsers only allowed that on a same origin request. Once that same origin sandbox broke and you could set headers on a cross-domain request, our entire CSRF protection system was bypassed. That was a fun week. So, if you do want to allow cross-domain requests and you want to set up CORS, there is a package allowing you to do it. It's called Django CORS headers. Now, I mentioned there was a bug in Flash that enabled this break of the sandbox. we are going to talk a little bit about Flash and its Microsoft world cousin, Silverlight, because Flash and Silverlight also have a same origin policy. They also let you override it. They don't use HTTP headers. They are big, gigantic software companies, Adobe and Microsoft, so they use XML, because that's what big, gigantic software companies do. This is an example of a Flash cross-domain policy file. This one in particular is useful because it disallows all cross-domain requests. Cross-domain policy files are served from the URL crossdomain.xml. They can specify other policy files to look in. Silverlight prefers one called client-access-policy.xml, but it does also look for and understand Flash policy files. If you want to set this up, it's a package called Django Flash Policies. It provides views for serving and utilities for generating Flash cross-domain policy files. Yes?
So I had a set of force headers a while back when I was making AJAX requests to subdomain. Are subdomains considered cross-origin or cross-domain requests?
Are subdomains considered cross-domain? I believe for the browser sandboxes, subdomain is considered same origin. If it isn't, I would be surprised, but I may well be surprised. I haven't looked at that a lot lately because I'm scared of cross-domain requests and just never allow them. In fact, the reason why that package exists is because I wanted to be able to send that out of Django and say, no, nothing is allowed. So, we've looked at how Django can solve the OWASP top 10. We've looked at some more in-depth stuff about how Django can help you. Have we solved everything? Are we secure yet? Is there such a thing as secure? Can't hear you. No, there isn't. So let's talk about some maybe further afield things. Timing is important for more than just comedy. Timing is important for how your software behaves. Who has heard of or is familiar with timing attacks? These are really fun. A timing attack is based on measuring how long it takes your application to do something. You can leak information through that. The easy and obvious one is, let's say I'm checking your password. You send me a password, I hash it, I compare it to what I've got in the database to see if they're equal. Python's really, really helpful. When you ask if two strings are equal, it looks at the first character of each one. If they match, it looks at the next character. It keeps going until it gets to the end, or until it finds characters that don't match. This means that how long it takes to do the equality comparison depends on how many characters you matched at the beginning of the string. That gives away information. If this seems arcane, it's not. You really can very reliably derive information from even the tiny little timing differences of looking at how many characters were compared. You say you start off, string of A, and see how long it takes to compare. Okay, well that didn't work. Try B, A. Did that work? Eventually, one of those, as you go through all the letters, or all the allowed characters, one of those is going to take just a little bit longer, because you matched one character at the beginning, and Python had to compare two characters instead of one. And then you go through all the characters again, and then it's going to take a little bit longer, because Python had to compare three characters instead of two. You can derive secret values one character at a time by paying attention to this timing. This is what's known as a side channel attack. This is, we're not really brute forcing something. We're not exploiting any theoretical weakness. We're simply exploiting the way your protocol behaves or the way your algorithm is implemented. So how can we stop this? One thing we can do is anytime we need to compare two strings for purposes of security, so say if we're checking credentials, we can make sure it always takes the same amount of time. The implementation is not all that interesting, but there are algorithms you can use to make sure that comparing two strings always takes a constant amount of time instead of varying based on how similar the strings are to each other. Django provides an implementation of this in django.utils.crypto, function called constant time compare. Django's authentication framework uses this internally. Anytime you're logging in with a password, the password check is done using a constant time comparison. If you're using Django's cryptographic signing tools, which we're going to talk about in just a second, anytime Django is verifying signatures and secrets, anytime Django is doing, I believe, CSRF as well, checking for match on CSRF tokens, Django uses constant time comparisons. Anytime you need to compare two strings that are security sensitive, use a constant time comparison. So let's talk a little bit about cryptography. Let's talk about the big scary thing. Cryptography is a gigantic topic. I cannot even give you the beginning of the hint of an introduction to it in a 3-hour tutorial. However, I can tell you there's a very important rule in cryptography, which is don't write your own cryptography, ever. Django has not obeyed this rule. Django has implemented some cryptography, but we went out and had people take a look at it, and we've had hundreds of thousands of people as well, because we're an open source project, take a look at it and beat on it and try to exploit it for money, because we have a bug bounty program where we will pay people who find bugs. So Django provides, the most important one, is an implementation of cryptographic signing, HMAC. It's available in django.core.signing. There's documentation on how to use this. This is a really, really, really useful thing. This lets you put a cryptographic signature on a piece of data as it's going out, and when it comes back, you can verify that signature and make sure that it was not tampered with or changed when it went out and came back. It's especially important if you're storing data client side. There are also other cases where you may want to use this. The Django signing implementation lets you check, is this a valid signature? It also lets you do a time-stamped signature, so you can check, is this valid and made within the last this many seconds? I've used this a couple places. I maintain a user registration application for Django. And one of the backends for it uses a 2-step create an account, send an email with a link to click to activate the account, so you confirm that there really is a person there. The key that it sends you is an HMAC signed value with a timestamp on it. So we can check, hey, did you click that activation link within 7 days, and is this really what we wanted? You can do more than just signing strings. You can sign arbitrary data structures using Django's signing utilities. For many years, people used a library in the, or used a module in the Python standard library called Pickle, which is for serializing Python data structures. Pickle is incredibly dangerous. Pickle is incredibly dangerous because deserializing a pickled Python data structure or Python object involves executing code. And you can end up executing arbitrary code that someone gave you because they gave you something pickled that wasn't what you thought it was. Django will sign data structures for you and serialize them safely. Under the hood, it's using JSON instead of Pickle. Please never, ever, ever use the Python Pickle module to serialize data that will go out to client side and back. If you can avoid it, just never use the Pickle module at all. So earlier, I gave you the guessing game of which of these are SSL vulnerabilities and which ones are mind control keywords from the Avengers. Breach. Spoiler alert, breach is actually one of the SSL vulnerabilities. Breach and crime. And I have a note here to remind myself of what these stand for. Does anybody want to guess? These are acronyms. Breach is browser reconnaissance and exfiltration via adaptive compression of hypertext. And crime is compression ratio info leak made easy. I don't know when the trend of inventing acronyms and branding for SSL vulnerabilities began. I'm not sure I really like it. But breach and crime were very similar attacks against SSL. They were attacks against compression. Has anybody ever turned on the gzip middleware in Django or turned on gzip compression on your web server to serve compressed responses? So basically you're sending out some HTML and either Django or your web server will gzip it on the way out. We apply a HTTP header to tell the browser we did that. The browser unzips it on the other end. Did you know that that's a potential security problem? It is, because of the way compression algorithms work. In particular, in this case, the HTTP deflate algorithm. But there are a lot of algorithms that this principle can work against. The way that compression works is it's looking for repeated sequences inside the content. And if it finds a repeated sequence, it will replace all instances of it with a shorter sequence and maintain a mapping of this short sequence expands into this longer sequence. There's a problem here, sort of similar to the timing attack, which is, what if there's a value that's in every single response you send out? Now, that response is compressed and encrypted, so you don't know what that value is. But what if you can make a bunch of requests and send data that you know will come back, like say in a form? And what if you start trying a bunch of characters and you notice the length of the response changes? That means something you sent is a match for a prefix of something that's in the output because the compression algorithm noticed it and replaced both instances of them with something shorter. Once again, it takes a lot of work, but it is absolutely feasible, one character at a time. If there is a constant value in all of those responses, you can figure out what it is from watching the behavior of the compression algorithm and watching as the length of that response changes. Even though you can't decrypt it, even though you can't decompress it, you can tell from the length of it what is going on inside. And you could recover, say, the CSRF token. And now you can bypass CSRF protection. You could recover a session ID. You could recover all sorts of things. The big vulnerability here was the CSRF system. Django's CSRF system was rewritten in Django 1.10 specifically to mitigate breach. What we do now is, instead of having a CSRF token tied to the session and having it go out on every response, which is breach, that's the attack, now what we do is we generate a secret that's tied to the session, and on every response we send out, we derive a new unique one-time value from it and send that out. So there is a different CSRF token value in every response, but they're all derived from the same secret, which lets us validate any of them. Is that scary? Sorts of things you can figure out that maybe you didn't think you could figure out. SSL is really, really scary. SSL is full of attacks and vulnerabilities and misconfiguration options. I recommend, and a lot of people recommend, this guide or set of guides for figuring out how to set up SSL safely, get the right configuration. There are problems with which ciphers do you allow. There are problems with which, configuration parameters do you pass in. There are all sorts of vulnerabilities with SSL setup. This is a topic you just have to go educate yourself on and get a good, solid set of recommendations to start from. This will help you. And this is just the beginning. We have not even covered a fraction of a fraction of a fraction of the things that can go wrong in your code. But this is the point where we're going to sort of change directions a bit. We're going to dive into something a little bit different. We're going to talk about Django. We're going to talk about security issues in Django. You remember I said we average one disclosed issue every 66 days. That means there's a lot of material to draw on where we've screwed up. Before I go into that, though, want to pause. If anybody has questions or anything they maybe want to hear a little bit more about from any of the sections we've been through before, are we good? Going once, going twice. Okay, so we screw up. It's a thing we do. It's a thing we've done and will continue to do. I mentioned Django's very first vulnerability was a command injection issue. It was disclosed in August of 2006. Django's most recent vulnerability, you remember that quote about is safe URL being a bad name because there's no such thing as safe in URL? Django's most recent vulnerability was last month. Redirect and possible cross-site scripting attack from is safe URL not being able to correctly validate some types of numeric URLs. I've mentioned we average one every 66 days, which means if you want to do the math and you know exactly when Django was first released, and I told you earlier when that was, you could figure out how many other issues there were. Anybody want to take a guess? Yeah. How many? 96? Too high. We'll probably get there eventually, but too high for now. Between the first and the last, there were 63 other vulnerabilities and issues. We do maintain an archive of every single one of them. So we'll tell you what they were. If there's a CVE identifier, that's the Common Vulnerability Database where you can look up all sorts of security issues and all sorts of different pieces of software. We list the CVE identifier. We will link to the blog post where we publicly disclosed it. We will also provide the patches for each affected version of Django, as well as links to download the newly released versions of Django. That's 65 vulnerabilities in 12 years, one every 66 days. We fall down a lot. We screw up a lot. And we're allegedly good at this. That still amuses me that people think that. But there are things we can learn from this. The first thing we can learn is Django originally did not have a security policy. This was a bad idea. Django does now have a security policy. You can read it anytime you want, including right now if you want to, by going to www.djangoproject.com/security. That will redirect you to a page in the documentation, which is the latest iteration of our security policy. Django was not always trying its best to help you with security. This is something that has evolved over time. When Django first came out, not only did we not have a security policy, we didn't have a 1.0 release, we didn't have a security reporting mechanism. Django didn't have most of these security features we've been talking about. It took years to get these in. Django 1.0, I remember we turned on template auto-escaping for the first time. That was incredibly controversial. People argued forever about, well, I don't see why we need template auto-escaping turned on. I just remember to escape my variables when they have user content in them. Why are you too stupid to do that? Turns out everybody is too stupid. Everybody screws that up sooner or later. And if you screw it up, you've just handed over the keys to your entire application because you have a cross-site scripting vulnerability. Yeah?
With that in mind, you were showing us a lot of the talk of the security middleware. Is there any thought to put those in the settings .py file and have them enabled by default?
Like to just have all of the things in security middleware be standalone settings and not require security middleware? It's tricky. So template auto-escaping is on by default because cross-site scripting is rampant. CSRF protection is on by default because CSRF is rampant. A lot of the things in security middleware only make sense. For example, HSTS only makes sense if you're serving over SSL, which is no guarantee that you are. You should, but Django works just fine under plain HTTP. So if we put that in there and turn it on by default, we're going to lock people out of their site the first time they try to hit the development server because it's sending an HSTS header. A lot of the things in security middleware basically are things that you really should have on if you're trying to follow best practices, but unfortunately not everybody will do that. Or not everybody's configuration will be the same, so that you can just turn that on out of the box. It's unfortunate. So, but anyway, it took us a long time to get to where we are now. I can talk a little bit more about that at the very end. But we've screwed up a lot. We've had a lot of issues. We've had a lot of vulnerabilities. What I want to talk about here is selections from the greatest hits catalog of Django's security issues and look at some themes and some patterns. For example, who's familiar with the accept language header in HTTP? This is a way you can specify in your browser. You can set a preference saying what languages do you prefer things to be in. So if a site is multilingual, it can decide dynamically what language to serve to you. And you can specify, like a lot of will just say English by default, or French by default if you're in France or in Quebec, or German by default, or whatever your language is. A lot of browser packs come with them set already based on where you downloaded it. But this header can specify multiple languages and can specify preferences between them relatively. So you could say, well, I'll take English or French or German, but if you only have English and French, I prefer English, but if you don't have English, I prefer German over French. You can do this sort of thing in the accept language header. Except parsing that out and deciding what's the best language from the ones we have available is really expensive to do on every request. So we decided to speed it up. Every time we parsed an accept language header, if we'd seen that value before, we kept a dictionary in memory of the value of the header and then what it actually parsed out to. Password resets. I mentioned password resets are hard. Django uses a one-time token to do password resets. That token is base 36 encoded. Base 36 is the 26 characters of the alphabet plus 10 decimal digits. That seems like a perfectly fine way to do things. Form sets. Anybody used form sets in Django? Kind of a scary feature. Let you have a form that, multiple instances of filling something out, and you can even dynamically grow it. So like in the admin, when you're adding an inline object, you can click add another, add another, add another, and it keeps adding more subforms on there. So form sets needed to be able to dynamically grow the number of forms they were going to use. Password length. Everybody knows you should have a minimum password length, but restricting how long a password can be, that's just dumb. You've seen sites that do that, and you're like, what the hell, man? I want to use a 50-character password. Why won't you let me? See, everybody knows that long passwords are harder to crack. Long passwords are better. Anybody want to guess what all of these slides had in common? They resulted in vulnerabilities in Django. So remember, we said, okay, the accept language header. We're going to keep this dictionary around in memory where the keys are the values of the header, and then the values are what it parsed out to. Oops. It was a denial of service attack. Turns out, somebody could send a really, really long accept language header. And then they could send that 10,000 times with slight variations. And we would keep all of them in that dictionary in memory. Turns out that eats a lot of memory. It's a denial of service attack. We do still store accept language headers in memory, but now we normalize them to a shorter form before we store them. Password resets, using that base 36 token. Turned out we weren't validating the length of the token. You could supply any base 36 value in the URL and Django would accept it and try to decode it, like a value this long. Do you know how large a number is when it's this long and it's base 36 encoded? You can eat up a lot of cycles trying to decode that. We now limit the password reset token in length to 13 characters, which is enough for any 64-bit integer. If you need 128-bit integers, you're on your own. So form sets, being able to grow the number of subforms they show. Well, turns out that there's a max num parameter you can set on that. If you didn't explicitly set it, it was read from a hidden field in the form, which the user could submit. What happens when you submit a value that's larger than, say, Python's maximum integer? You get an overflow error, which is an uncaught exception, which crashes you, which is a denial of service attack. Now, if you don't set max num on a form set, there's a default of 1,000. You can't go larger than that, and I really don't understand why you would ever need 1,000 subforms in a single page displayed. This one's my favorite. Denial of service via large passwords. This gets into hashing algorithms. I mentioned Django defaults to PBKDF2. And we've had some problems, because the way you tune PBKDF2 to make it safer, make it more secure, is by changing how many iterations of the algorithm you do. For a while, our target was over 100,000. We wanted to get there, and we were raising it every single release of Django. We would raise it a little bit. But older versions of Python, the hashlib module did not contain an implementation of PBKDF2. Newer versions of Python have an implementation, and it's written in C, so it's fast. In order to use PBKDF2 on those older versions of Python, which Django supported, we had to ship a pure Python implementation of PBKDF2 in Django. This was slow, because it's Python as opposed to C. And every time you increase the number of iterations, the same thing that makes it safer, because it's harder for someone to brute force their way through a bunch of hashes, also made it harder for your server to check someone's password when they logged in. And especially for a larger value or a longer value, it was pretty bad, because in addition to shipping our own implementation of PBKDF2, we were feeding values into later iterations in a way that wasn't very efficient and made it take even longer. So we temporarily in Django actually had a restriction on how long a password could be because of this problem with PBKDF2 performance. We have since corrected the implementation of PBKDF2, lifted the limit, so now you can have unlimited length passwords again, and we're about to, I believe, either we are as of Django 1.11, or we will be as of the next release, which is Django 2.0, only running on versions of Python that ship an implementation of PBKDF2, so we can finally get rid of our own implementation of it. So the theme here, Python is a great language. Python makes so many things easy, and Python takes away so much of the bureaucracy and annoying things you have to worry about in other languages. You don't have to keep track of memory. You don't have to keep track of all sorts of things that you would be doing in C or C++. But you can still open yourself to some vulnerabilities in Python if you're not careful. And especially it's easy to cause a denial of service attack against yourself. So what did these have in common? We were not checking inputs before we started processing them. We were not checking the length of a password before feeding it into an inefficient hashing implementation. We were not checking the length of an accept language header before using it as a key in a dictionary. We were not checking the length of a password reset token before we tried to decode it. This is a thing that you should learn from us. We screwed up a bunch of times. Learn from our example. Learn from the security vulnerabilities littered on the side of the road by our mistakes. Check the length of things before you process them. Configure your web server. Your web server lets you cap the length of HTTP headers and the length of request bodies. I guarantee they have a feature for that in your web server, if you're using a good web server. Figure out how to configure that and do it. Let's look at a few more things. URL field. URL field accepts URLs. It's for storing URLs in your database. Should really check whether the URL exists before accepting the value. Is this a feature that anybody remembers? Because this feature doesn't exist anymore. Does anybody remember verify exists on a URL field? Okay, only the grumpy old man up here remembers it, because I am the grumpy old man of Django. It's actually, I've petitioned for that to be my official role in the Django team. URL field should accept anything that matches the format of a valid URL. This seems perfectly reasonable. We want to validate that it is a URL, right? And while we're at it, we have an email field. Email field should accept anything that matches the format of a valid email address. This is a thing that every 4 to 6 weeks, there's a gigantic thread on Hacker News where you should not ever read the comments, but you do anyway. I know you do. I can see you all looking guilty. You should not read those comments, but there will be a thread where somebody, proudly proclaims that they have an email address that does something that is technically allowed by the specification, and it's your fault if you don't recognize that as a valid email address and accept it. And why don't you follow the specification and allow anything that's allowed in an email address? Django allows you to upload images. Checking image formats is easy. We want to check if they're corrupt. There's lots of easy ways to do this. There's a library on Python 2 when it was maintained. It was called PIL, the Python imaging library. Then that stopped being maintained, and now there's a Python 3 compatible version forked off of it called Pillow. Makes it easy to do that. Also, image formats store a lot of their metadata in headers that are at the very beginning of the file. And it's easy to find that metadata, like how big is this image? How many pixels wide by how many pixels tall? We can just read a few bytes of that header at a time until we've got the whole thing, and then we know all its metadata. You probably know what's coming now. So URL field had this option called verify exists. When you submitted a form with a URL field in it, Django would attempt to make a request to that URL to see if it worked, and would raise a validation error if it didn't. What if you set up a web server that will respond on the URL you just submitted, but will take a really long time to do it, and tie up that process on your server while it's responding slowly? So slowly. And then you submit it a bunch of times and tie up every process on the web server waiting for these slow responses. Turned out there was no way to make verify exists be safe or anything close to safe, so it was removed. So URL field and email field. These were validated using regular expressions. And once again, someone on Hacker News will say, well, you say regular expression, but really there's a formal mathematical definition of that. You mean regexes because you mean things with backtracking. So that's just me commenting for the video to the person on Hacker News who's going to be annoying about it. Denial of service attack via pathological regular expression performance. Pathological is both a technical term and a really good description of how the regular expressions for a URL or an email address behave. There are inputs you could pass to those regular expressions which take a really, really, really long time to determine whether they match or not. Especially if, say, you're open source and the regular expression is in the source code where everybody can read it and they can specifically craft inputs that are designed to make it take a long time. It takes a long time. We simplified the regular expressions that we use for URLs and emails. We still do actually use regular expressions. They're just not as complex as they were, and they don't allow as many things as they used to. Denial of service via compressed image files. This was us using PIL to look for corrupt images. Who's heard of a zip bomb? A zip bomb is a zip file which contains a zip file, 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 and it's zip files all the way down. What happens when you try to decompress that? The answer is it consumes all the resources on your machine. There were some problems with trying to do image checks that could run into things very similar to zip bombs with compressed image formats. Now we don't do as many of those checks for corrupt images as we used to. We were just trying to be helpful, but it was a security issue. Then, of course, there's denial of service via large image files. This is where we were reading the header of the file to get things like the dimensions of it. Turns out, not every image format has a header with that information in it. Some image formats, you have to read the whole file to figure out the dimensions. And if you're reading it only a few bytes at a time, and the file is very large, that takes a while. If someone uploads an image in one of those formats that's very large, and then uploads another one in a different tab, and then another one, and then another one, once again, they can tie up every process on your server. The answer here is exponentially growing reads, and this is a pattern that's really important to know. Anytime you're looking for something inside a file, for example, and you're reading a little bit of it to see if you've got what you need, double the size of the data you're reading every time you try again. So say the first time you read maybe 2 bytes in. Next time read 4 bytes, then read 8 bytes, then read 16. You will still get to where you're going. You will get there a whole lot faster than if you just read, say, 2 bytes at a time, every time. And you will avoid this problem. So what all of these have in common is a question we forgot to ask, which is, what's the worst thing that could happen? How hard could it be? Well, it turns out things can be really hard and bad things can happen. And we didn't anticipate very many of them. You can learn from our mistakes. You can stop and think about, how much work do I expect my code to be doing here? And then you can think like an attacker. You can think, how could I make it do more work than that? Using a regular expression? Does it do backtracking or back references? Could I exploit that to make it check over and over and over and over again? Is it reading something a few bytes at a time? Could I exploit that? Think about, how could I make this code do more work than I was planning for it to do? Then, this is the hard part, figure out ways for it to do less. And look up some of these issues. These are things that, I keep harping on this. These are things that are embarrassing for Django, for supposedly having a good reputation for security, to have had some of these issues, like zip bombs in images, or pathological regular expression performance. These are things that were known issues before some of the Django committers were born, and we still fell victim to them. Yeah.
Was it due to because I'm reading stats, in 2015, it seems like Django blew up with vulnerabilities from a CVE perspective. Was there a shift in management, from a development management stance?
Did something happen in 2015? I don't think anything necessarily happened in the organization of the team. I'm trying to remember when we started the bug bounty, because that may have been it. Because we do now have a bug bounty program where if you find a vulnerability in Django, we will pay you for disclosing it to us. So, to take an example, email addresses. How hard is it to do everything that an email address technically allows? That is a Perl regular expression by someone named Paul Warren, who wrote a module called mail RFC 822 address. It validates, according to its documentation, the full range of permitted email addresses according to the standard. And Mr. Warren has helpfully provided this comment, quote, "The grammar described in RFC 822 is surprisingly complex. Implementing validation with regular expressions somewhat pushes the limits of what it is sensible to do with regular expressions." Django does not do this. Django uses a much simpler regular expression that doesn't allow everything you can technically have in your email address, Mr. Internet Commenter. And we're better off for it because it means we don't have denial of service issues with pathological regular expressions. Let's talk about this one. Values of cookies that we set have been trusted. We set them. Why can't we trust them? Users of the Django, yeah.
I need to backtrack, but for something like where you allow, you guys simplify it, you allow,
Yeah.
is that something that can be overridden by its specific implementer so that they say they prefer to not have it?
So could you, if you wanted to have email field accept everything?
Yeah, just if they want to accept the range.
You can write your own email field that has denial of service vulnerabilities in it. You can use that email field instead of Django's email field. Django's email field does not let you configure the regular expression that he uses. You get the one that we use. Anybody who wants something different, you can still write your own email field and use that instead, but it will not replace the default Django email field. Same thing for URL field. So Django admin. If you look in there, you look at like a list of model objects, you can filter those. You can put things in the sidebar to filter them by different values and fields. You can sort them, you can search on them. All of this is very similar to the ORM lookup API. And in fact, if you look at the query string in your browser as you use the Django admin, you'll notice it is exactly the syntax of the ORM lookup API. We can trust admin users with that. What if they know the Django ORM and can just write out the lookup conditions they want in the query string? We can trust people who have access to the admin. You wouldn't just hand out access to the admin to someone you didn't trust, would you? I mentioned this one earlier. We can trust the same origin sandbox in the browser, right? Browsers will make sure you can't do cross-domain requests in JavaScript, right? The admin interface shows a log of the history of each object. We can trust admin users to be able to see that, right? Once we've validated a value and stored it in the database, we can trust it, right? We validated it. We know it's valid. You probably know what's coming here, right? We trusted values of cookies because we thought we had set them. We weren't escaping the value of the CSRF cookie when we sometimes used it, which meant you could submit it to us a cookie with some JavaScript in the value, and we would show it. Now we escape cookie values. Information leakage in the admin interface. This was where, this is true, if you look at that query string in the Django admin as you filter objects, it is exactly the ORM lookup API syntax. Used to be you could put any ORM lookup API syntax in there, and as long as you had permission on that model, you could do it. You had to have a user account with access to the admin and with permissions to view that model that you were filtering on. The problem is, how do we figure out whether you have permissions to view the specific set of objects that you're getting back and any related objects that you might join onto that? The answer is we can't. So now the model admin class has a whitelist of filters that it will allow, and it allows only those and no others. This was a really old feature of Django that basically grew out of it being developed in a newspaper environment, where you had some really technical admin users who needed to be able to filter things, and so it allowed them to, and it was never documented. It was never really encouraged. And then it was taken away because we couldn't make it secure. There's a running joke in the history of Django. The newspaper was called the Lawrence Journal World, but the online department was called World Online. There's a running joke in the history of Django that someone would commit a change that removes a feature, especially something undocumented, and the commit message would be, this should only affect World Online, because they were the only people who ever knew that this existed. This was one of those. CSRF via forged HTTP headers. This was one that we talked about, where the browser same origin sandbox got broken by HTTP 307 responses. Has anybody gone out and looked up what a 307 does? It's a redirect. You probably know 301 and 302 redirects. You know, redirect from here to there, either permanently or temporarily. 307 redirect is redirect and preserve the request method. If you issue a 301 or 302 in response to, say, an HTTP post, the browser will go to the new location, but it will not go there with a post, it will go there with a GET. If you send an HTTP 307 and say, go here instead, the browser will repeat the post request. So what you would do is you would exploit a bug in Flash that let you do this. You would make a custom request to a domain you controlled that was the same origin as the site that you were looking at, and have that respond with an HTTP 307 to the site you wanted to attack. And the browser would repeat that request as a post with any custom headers you set and with any data you sent. And that was the end of the same origin sandbox for a little while. So, the admin history log. This was a similar problem to the lookup API. We show a log in the admin of the history of an object, but securing this is hard. We've had several problems over the years because, again, how do we determine, we know you have permission to view this model. How do we determine you have permission to view this instance of this model? And how do we determine whether you have permission to view any related model instances that are attached to it and might get joined on? Or any data, maybe you're only allowed to see a subset of the fields. This is a hard problem, and we've had some issues with it. There was a cross-site scripting attack, which did not get a CVE identifier, one of only a couple in Django's history that didn't. When you were filling out a URL field in the admin, we would validate it. We'd validate, yep, that looks like a URL. And then when we displayed it again in the admin, we wouldn't escape it. Which turned out you could create a cross-site scripting hole by creating something that then someone else would go look at in the admin and execute JavaScript in their browser. Now we do escape everything we display in the admin. So now let's talk about, earlier I mentioned you should think about how many vulnerabilities has Django had related to the isSafeURL function. The time has come to talk about that. Who thinks we had one vulnerability? At least one vulnerability. Who thinks we had at least two? Who thinks we had at least three? At least four? 5? Do I hear 6? So let's look. 1, 2, 3, 4, 5. 5 times. You'll notice that's over a period of 2 years. 5 times in 2 years. And then just about a month ago, we had another one. So it's called a cache poisoning attack. How this works in this specific case is Django sometimes needs to construct a full URL, including a domain name. How does it know what domain name to use? Sometimes we can figure that out from the Django Sites framework if you're using that and have it configured properly. Sometimes we need to use the HTTP host header. In HTTP 1.1, you send a header called host that says, this is the host name, or most often domain name, that I want to get a response from. And servers can support multiple host names, multiple domain names running in the same web server instance, and use the host header to decide which one to serve off of. But now you have a problem. If you can get Django to construct a full URL using a host header that is not the domain Django is running on, you can get Django to issue redirects or display links to some other site that you didn't necessarily expect to have displayed. You might think, well, that's not so bad. I have to send input in that request, in that specific host header, so it's only me who sees it. The problem is we cache things. We cache things on the server side. We run HTTP caches and caching proxies in front of them. Your browser caches things. There are all sorts of places where that output might get stored and shown to someone else. If you can plant a link to somewhere else on that site and get it into an HTTP cache somewhere, you can send a lot of people to a bad place. So, how do we validate the host header? We tried several times to do this. As you can see, we tried 5 times. The first attempt had to do with running a proxy in front of your web server. Proxies are supposed to set a header called x-forwarded host to tell us what the original host header was. Can't trust that. Second one involved a problem with getHost, which is the method on an HTTP request object, trying to parse the host header. It involved specifically URLs which include a username and password in them, which is legal to do. How many people knew you can put a username and a password in a URL? You can do that. Especially if there's HTTP authentication on that URL, you can send that. It was a problem parsing those that could hide the actual domain of the request. The next attempt tried to restrict the character ranges allowed in host headers, because Unicode is much like JavaScript. It's useful but also a terrible, terrible threat. Finally, after 5 iterations, what we settled on is the current way Django does this, which is there's a setting called allowed hosts. And allowed hosts must be set when you turn off debug. You cannot run Django with debug equals false and not set allowed hosts. There's a list of host names that are allowed to appear in the host header, and Django simply applies very strict checking. Every time a request comes in, it looks at the host header, sees, is that host header in the list of allowed host header values? If not, bail out with an error, because that's the only thing we can do. Now, what did all of these have in common? We inappropriately trusted things. We trusted things we should not have trusted. And I don't know about you, I was a kid, well, not a kid, I was a teenager in the 90s, and so I should have learned this lesson a long time ago. Unfortunately, I didn't. Trusting things, trusting people, trusting your friends, trusting people you meet at a conference can be good. When you're writing software, trusting things is bad. Trusting data is bad. Trusting behavior is bad. You have to be defensive and expect every piece of data to be malicious. You have to expect every service to attempt to exploit you. You have to behave as if nothing can be trusted. There's a famous paper called Reflections on Trusting Trust, which presents an interesting approach to designing a C compiler with a backdoor that when it's compiling a login program will sneak in a set of credentials to allow someone to log in with them, and then explaining how you could hide that and set it up so that even though you no longer have that code in the source code you're compiling, the compiler itself ends up containing the code, and every time it compiles the login function, sneaks that code in even though it's not in the source code. You can't trust anything. You can't trust your compiler. You can't trust your processor. Has anybody been following along with the Intel Management Engine fiasco? Has anybody heard? Who's heard of the Intel Management Engine? You probably have one in your computer. You're trusting it whether you want to or not. You probably wish you didn't have to trust it because it's not trustworthy. It has bugs. You can't trust anything. We learned this the hard way. That was what, 5, 6, 7, 8, 9, 10 vulnerabilities related to inappropriately trusting things, and those were just the ones I could find quickly. There are probably more of these. But hopefully I've gotten the message across. Now, I want to offer you all a choice, because there are two things I can do here. We have about half an hour left in our time slot, because we apparently took the break too short. So we have about half an hour left of the scheduled time. There is a section of these slides that I can add back in that covers the history of how Django has approached security, when things were added, and I can tell some stories about that. Or we can take a much longer than expected question and answer session. What do you all think would be most useful? What would you get the most value out of?
I'd like to know what practices that you're using for verifying the security of Django and how that could be practices.
Okay. Okay. So, yeah. It's okay, yeah. I can talk a little bit about security processes at Django. So I mentioned we have a security process online at djangoproject.com/security. And I am going to quickly, while I'm talking, throw a bunch of slides in here, because I do still have them. Django originally did not have that security process. It was added, I want to say, around the time of Django 1.4, and I'll be able to tell you for certain in just a moment. There we go. I told you I had some slides prepared for this. So, let's go back to the beginning. Django was released on Bastille Day 2005. At the time, security, what a mess. The very first vulnerability in Django that I listed a while back was in August of 2006. The way we disclosed that was to put up a blog post and say, well, someone found this potential issue, but we don't think it's very exploitable. And the fix for it was, we've committed a new version of that file to Subversion. Just go grab a copy out of the Subversion repository and copy and paste it over the version in your copy of Django. This was not a good process. It's a really bad process. It's a really terrible process. But at the time, we were still learning, and the Django team was still very small. Django itself was getting some press, but still had not really taken off. It's 2008, Django 1.0. Big thing there was escaping template output. People, like I said, argued about this forever on the mailing list. Finally, it was just, look, we're doing it. We have to do this. And if you look at Django's history, if you look at that archive of security vulnerabilities in Django, the number of times that we have gotten it wrong, we're supposed to be the experts, we're supposed to be good at it. The number of times we've forgotten to escape something in the admin or somewhere else, no. Nobody is good enough at this stuff to not need the auto escape. Next up was Django 1.2 in 2010. The CSRF protection module used to be in Django.contrib. It became part of Django core, and it was on by default. Originally, you had to turn that on to get CSRF protection. Then 2012, Django 1.4. And this is when you kind of start to see the change in Django. This is when people started looking at Django as a framework that was taking security seriously. Django 1.4, we switched to PBKDF2 as the default password hashing algorithm. We shipped the implementation of HMAC signing in Django. We turned on signed cookies. One of the things Django will do, we have that implementation for signing things and making sure they weren't tampered with. We will sign your cookies for you to make sure that your users aren't tampering with them. We added clickjacking protection. We added the error scrubbing functionality with sensitive post parameters, sensitive variable names. And we added the formal security process, which is now on our website. Django 1.5 and 1.6, we got better at password storage. all of those host header issues happened. Django 1.7, the system check framework, manage.pycheck was added. Now you can have Django look at your configuration, look for common problems, look for common misconfigurations, and also add in your own checks. 2015, Django 1.8 came out. The system check framework now has the deployment check, including security middleware. Security middleware is now part of Django. Security middleware, I've mentioned several times, is one of my favorite things in Django. It took us 10 years to get it in there. Django 1.9, in 2015, password validation framework was added. The permission-based mix-ins for class-based views were added. Django 1.10 and 1.11, the only thing I can think of, I don't have a slide for those, the only thing I can think of is because Django 1.10 rewrote the CSRF system to avoid the breach attack. So, we have a security process and a security policy. We didn't have that originally. Goals of this process: protect you and protect the people who use the software you write. We want to encourage responsible reporting and disclosure of security issues. We want people, when they find an issue in Django, to tell us about it and let us fix it, rather than exploiting it or selling it to someone who will exploit it. Django is now used by some very large organizations with a lot of users and with a lot of really sensitive data. It's a really bad thing if there's a vulnerability in Django that can be exploited to get to those users or get at that data. So we have a process. It begins right there. If you ever think you found a security issue in Django, please email security@djangoproject.com. Please do not file a public bug first. I mentioned the story of how I once had to roll an emergency security release at 1 o'clock in the morning in a hotel room in Denver. That was because someone reported a security issue to the public bug tracker instead of emailing security@djangoproject.com. Turned out what they'd found was not just a bug, it was an exploitable denial of service vulnerability. Once you have reported the issue, we will work with you to verify it. Sometimes it's not a bug. Sometimes it is a bug, but we decide not to consider it a security bug. There are some criteria for that. They can be a little subjective. Once we've decided it is a bug, and it is a security bug, and we want to invoke our security process, we begin tracking it in a private issue repository. Django has a public instance of the track bug tracker at code.djangoproject.com. You can look at the full list of tickets and bugs and feature requests for Django. There is also another Django bug tracker that is accessible only internally to members of the Django team, where we track security issues. That's where we begin working on it. Once we have a patch for the issue, we request a CVE identifier, so that we can refer to this vulnerability by a standard identifier. It goes in the common vulnerability database. And we trigger our security pre-notification process. This is the point where I mentioned we do have a security pre-notification process, and as much as I like each and every one of you individually as humans, you probably can't be on it. Why we have a security pre-notification process? There are a lot of operating systems now that ship a packaged version of Django. There are a lot of very large and very sensitive deployments of Django. Those are major, major, major vectors for bad things to happen. So we have a small list. Criteria for getting on it are pretty strict. You can see in the security policy what they are. People on that list get notified of Django security issues 1 week before they are publicly disclosed, and they get a copy of the patches. Mostly this is so that, for example, on the day we disclose an issue, if you're running, say, on Red Hat Linux, and you're running the system Django package, you will be able to just run your system software update and get a new version of Django with that patch applied, because Red Hat already knew about it, already prepared a package, and had it ready to go on the day we disclosed the issue. That's why we do that. It is not meant to be exclusionary, but in order for that list to be effective, it has to be very small. If you are ever setting up a security policy for an organization you work with, and you feel like you need to do pre-notification of issues to a third party, you can do it. We do it. Keep that list small. 1 week after we send the pre-notify list, we go public. Once upon a time, remember, we told people to go download this new copy of the file and overwrite it in your copy of Django. Now, every single time we do a security release, we do a real release. We release entirely new packaged versions of Django. We put up a blog post with details of the issue. We link to the commits on GitHub, which fixed the issue in each version of Django. We tell you which versions were affected. We link you to the packages that we've just released. And every time we do a Django release, every time, this is a contentious thing because it's not built into pip and maybe can't ever be. We don't just put up a package. We put up a PGP signed file containing checksums of the package. You can go to Django download page, djangoproject.com/download, and you will see a list of packages to download, and each one of them also has a checksum file. And you can look at that checksum file. If you have PGP installed, you can go grab the key that was used to sign that. It's going to be Tim Graham, who's the current release manager. It used to be me. Before that, it was Jacob Kaplan-Moss. You can verify that that file was signed by that key. You can then verify the checksums in that file match the package you just downloaded, and you know that what you just downloaded is what we intended for you to get. And then once we've released, we wait for the next issue, because there will always be one. 65 so far in 12 years. I don't know when the next one's going to hit. Maybe there's one right now that I can't tell you about. I couldn't tell you if there was. There will be another one. Because, as I said at the beginning, there is no such thing as secure. There is no such thing as insecure. Security is not a binary. Security is not an absolute. We are supposedly good at this, and we've failed 65 times. We are supposedly good at this, and we are going to keep failing. The slide I had earlier said we fall down a lot. The important thing is not whether we fall down, the important thing is we get up and we keep trying. I have learned a lot of really scary things as a result of working on Django, and as a result of being on the security team for Django, and of seeing some of the things that come in to the security address. A lot of things that I wish I didn't have to know. A lot of things that I wish I didn't have to worry about. Security does that to you. My mind was unsettled. Perhaps now your minds have been unsettled. But there is no such thing as secure. There is only the best we can do right now. There is only trying to learn about these things, trying to learn what we can do about these things for now, trying to develop policies and processes and keep security in mind as we do our jobs, and have a plan for what happens when we fail and how we're going to get up and respond to it. Because it's going to happen. And if anybody wants to open a betting pool on when Django's next vulnerability is, we're said average every 66 days. Our last one was April 4th. So that gives you a target. We now have about as much time as I expected for questions, which is to say about 15, 20 minutes. So, who has questions? Do we use fuzzing? Not at the moment. Does everybody know what a fuzzer is? Or encountered fuzzing? Fuzz testing is when you throw just random junk values at a piece of software and see what happens. One of the greatest tweets of all time was a joke. A QA engineer walks into a bar and orders 1 beer, 2 beers, 100 beers, 999 beers, ABQ beers. This is what fuzz testing is like. You're just throwing things at the software to see what happens. And there are software tools, fuzzers, which will do this. There are even really advanced fuzzers. My favorite one is one called AFL. AFL is really cool. AFL can watch not just what the output is and not just what happens when it runs a program with some input. It can actually hook into tracing and figure out what code paths are being executed inside that code and start figuring out, well, what does the expected input look like and what can I throw at it? There's some really cool blog posts about AFL where at one point, just by letting it run for a long time against a JPEG decoder library, AFL started to figure out from iterating its own random input what a JPEG image looks like and what the file structure looks like, and was generating valid JPEGs as input. Fuzzers are really cool. We do not currently use a fuzzer against Django. We also don't use any static analysis tools on Django's code base at the moment. That's another thing you can do. It's more common in statically typed languages, where you can run static analysis tools that just look at the code without executing it and try to look for dangerous patterns or potential issues. I don't know that anyone's really pushing static analysis on Python right now, but it would be kind of cool now that we at least have annotations and type hints standardized, if somebody wanted to try it. There is an open-ended project to potentially annotate and type hint all of Django's source code. I don't know that it's ever going to happen, because Django's source code is kind of scary and does some very, very dynamic things that you may not be able to usefully annotate. But there is an open project to try and do that. So yeah, those are two cool tools that you can have in your toolbox. Django doesn't currently. Fuzzers and static analysis. Questions? Anybody? Yeah.
So for REST APIs that don't necessarily, that totally like use Django way, and I guess we use course headers as well. What are kind of some security measures that we should take on REST API front, as opposed to?
What are some security measures for REST APIs as opposed to templated HTML? Yeah, and using Django REST Framework, yeah. Obviously, Django REST Framework comes with its own pluggable authentication system and permission classes and authentication and authorization classes. You want to make sure all of that is configured correctly. Authenticating to REST APIs is tricky, because usually what you have is a REST API running on a server somewhere. And these days, often what you have is a front-end JavaScript application written in React or Angular or some JavaScript framework that behind the scenes is doing requests to that API to power the application. The question is, where do you log in? And how do you make sure both of those components know you're logged in and know who you are and what you can do? And that can be kind of tricky. I've seen people use JSON Web Tokens for that. There are also a lot of people who will tell you to never ever use JSON Web Tokens for that. In fact, if you just Google for "don't use JSON Web Tokens for sessions," I think you'll find some very interesting articles. JSON Web Tokens are JSON objects that carry assertions and signed values in them. Basically, they let you do things like use a cryptographic signature to generate a token that lets you verify, hey, this really is the person I think they are, or hey, this person has a permission to do a thing. Basically, whatever the text of the token is, you're using cryptographic signing to say, yes, I have verified the claim that this person is making. If you ever used Mozilla Persona or Browser ID, as it was called at one point, it was an entirely JSON Web Token-based authentication system. You would get a token from your email provider saying, yes, this person has proved to me that they are who they say they are, and you would present that token to other sites as a way to log in as that email address. The problem with JSON Web Tokens is that the problem is their advantage. The advantage of a JSON Web Token is you don't have to store state on the server because the token contains in it everything you need to verify. It contains the assertion and it contains the proof of the assertion. So it's really tempting to say, well, I don't need server-side sessions now. But the problem is you can't easily revoke a JSON Web Token. You can expire them, and you can set really short expirations, but if you set really short expirations, you're having to issue new tokens over and over again, which gets you back to server-side state. So there's this long-running conversation about, well, what is the best way to do authentication to these types of APIs? I don't know that there is a single correct answer. I don't know there's a single generic answer. A lot of the stuff I've read about JSON Web Tokens makes me kind of wary of it. I also haven't done a lot of work personally in that space, so I don't know what other options are out there. Everything I work with personally right now uses OAuth. Maybe switching to something else in the future, but everything that I've worked with at my last couple jobs used OAuth, or at least when we were doing something like that. As for other REST-specific stuff, APIs can be kind of scary to build because they feel like they're a little more unattended, that there's not necessarily a user directly seeing things going on, and maybe not as much error reporting or surfacing of errors. I would want really, really, really good logging. I would want really, really good tracking of everything that's going on, and I would want to very carefully audit everywhere that I'm allowing HTTP methods and what methods I'm allowing. That would be sort of my starter kit for auditing a REST-based app. And then I would go listen to whatever Tom Christie says, because Tom is the author of Django REST Framework. Cool guy. Yep. The allowed host setting, like if you're already using virtual servers in the web server config, you mean? Allowed host is still something you have to set, because if you didn't set it and just trusted your web server, well, you notice that word trust. Don't trust your web server. Don't trust anything and don't trust anyone. Anything else? I bored you all to death by talking at you for 3 hours?
Maybe speak to a different vector of security, which is detection. Any insight into how we should monitor our systems so we can identify that maybe bad things are happening?
So how to do detection of bad things? That's one that's going to be a mix of things that are very specific to your application and your domain and what you care about. You can do some basic things. You can do rate limiting. You can do logging on, say, request bodies over a certain size. You can make a list of things that you think are going to be suspicious and configure logging to happen on them. The problem is that there aren't necessarily a lot of universally, well, this is suspicious. There are some, and in fact, Django has a built-in exception called suspicious operation, which it raises when certain things happen, usually when expectations of security-oriented features of Django are violated. When we were expecting something to be a certain way, and we can't necessarily say someone's trying to exploit it, but we can say that looks fishy, Django will raise a suspicious operation. I would say that's a case for, you probably want to go to the threat modeling talk on Friday and spend some time doing threat modeling work and decide what are the things we're worried about people doing in our application. Because it might be anything. It might be dealing with size of inputs. It might be rate limiting. It might be Even further back, it might be things like looking at pre-commit hooks for your code base to make sure things don't get snuck in. Lyft has a great plugin for OpenStack Bandit, which is a static analyzer for Python code. Lyft has a really cool plugin for that they use to keep themselves from accidentally committing passwords and API keys into their source repository. Like, there are all sorts of things you can do with that, but it really depends on what is your threat model and what are you worried about. Yeah.
And to answer your question, there isn't really anything like CAN. We're building out a program currently internal to do exactly what you're talking about. It's like the data science model.
Yeah.
There's a whole big security initiative to do that specific action. You can use like lambdas and anything in AWS to actually build out a logging initiative
Yeah.
from Django to like a lambda-based database so
Yeah.
that you can action on quicker.
Cool.
I was kind of going towards inherently secure, within the Django development process, within the code gets pushed, within the code reviews that happen, how do you drive inherently secure stuff? How do you raise the trust? By making
Yeah.
sure the things that you say happen.
Yeah.
Check.
Yeah. Django's own code review process for code that gets into Django. This is misbehaving. So first of all, we have a larger group than we used to, but we do have a small group of committers, people who have access to do that. And we have hard requirements that any patch that we accept has to include documentation of anything it changes and has to include tests. Tests have to pass. There is a process for verifying it. There's a style guide. You have to read through it. Designed to standardize the code base as much as possible to make it easy to spot problems. Also, we do take some steps to make sure that when you ask for a copy of Django, you get what we wanted you to get. So that it's not just we're controlling what we're committing, but we're controlling that what you get is what we committed. We also use a lot of cryptographic signing. Like, we don't just do the sign checksum files, we also sign all our get release tags. But it really, at that point, is a manual process of the people who are empowered to review and merge a patch are people who we've vetted and trusted. And that's not something we can automate, unfortunately, at this point. Yeah. Okay, we're just about exactly 3 hours. Anybody else got something they want to talk about, or do you all want to go have some lunch? One more question.
Are there any issues you're aware of about trusting Django add-ons that users like Django access and track failed login attempts? Is there bad ways to do that? I know there's bad, but is there a best practice that you're doing?
Good ways to trust Django add-ons and third-party applications. I have like some personal heuristics that when I look at something for the first time, there are a lot of things that I will look for, like especially in its repository and its packaging, that tell me personally whether I think this person has their stuff together and knows what they're doing. But that's, again, that's kind of subjective. Like, I'm going to look for, do we have tests? Do we have passing tests? Do we have CI set up? Do we have documentation? Do we have proper packaging? Do they have a contact point for security issues? Do they have a history of releases? Yeah. Yeah. It's not built into Django. You can do rate limiting. I don't know if it's built in or if it's an add-on in Django REST Framework. I know Django REST Framework has documentation on how to do throttling and rate limiting. But it is all at this point third-party add-on. Anything else? Going once? Going twice? Go to lunch.